Okay, students, this is Chapter 9, Lecture 6. This is reconstitution of powders or crystals into liquid medication. As usual, my disclaimer is that you should have already read the chapter, reviewed the PowerPoint, and read the lecture notes that's provided to you guys within Blackboard prior to reviewing these lecture videos and completing the assignments. Now, what I'm going to do now is I'm going to present to you guys some additional practice problems that I've created. And you're going to solve those problems just as you would if it was given to you in the book with a nice pretty label. But all of these problems that I'm providing to you right now are basically problems, word problems. They're practice. They're powdered drug word problems. And so we're going to solve them the same exact way that we were doing within the book. But of course, you're not going to be asked all those different questions. All right. So let's start with number one. Number one reads that you are to reconstitute 1 gram of dry powder. The label states that you are to add 9.3 milliliters of diluent to make a final solution of 100 milligrams per milliliter. What is the powder volume? So first things first, you're going to pull out these numbers and you're going to identify each of those numbers so that 1 gram is considered your what? Your total dosage. In detail, your total dosage is what? The weight of powder. That's how much the powder weighs. All right. The next number that we are going to pull out is this 9.3 milliliters. That 9.3 milliliters in detail is your what? Your DV. Your DV is your what? Your diluent volume. All right. The next number we're going to pull out is 100 milligrams per milliliter. So that 100 milligrams per milliliter is considered your what? Your dosage strength. And because you only have one dosage strength, then this medication is considered, a what? A single concentration medication. Because you're only provided one dosage strength. All right? Well, the question is, what they want us to do is they want us to calculate what the powder volume is. Well, remember, in order to solve that, your formula for powder volume is PV equals FV minus DV. Well, you know you're looking for the powder volume, and the only component that you have in order to solve this problem is your what? Your diluent volume. That's the only thing that you have. So the next thing that you need to do, the first step that you need to take, so I'm going to say step 1 is to determine the final volume. In order to do that, you are going to take your total dosage over the dosage strength in milligrams, and you're going to multiply that by the dosage volume, which should be in milliliters. So we're going to solve that. I'm going to change my color to a blue. So my total dosage we know is what? 1 gram, but if my dosage strength has to be in milligram, then my total dosage needs to be in milligrams. So that's 1,000 milligrams over My dosage concentration again is what, 100 milligrams. And I'm going to multiply that by the dosage volume of 1 milliliter. Milligrams cross out. So I determined that my final volume is 10 milliliters. You just calculated your final volume. Now you can solve the problem. PV equals FV minus DV. Well, powder final volume is 10 milliliters. The diluent volume that was added to the container, you guys, was 9.3 milliliters. Let's just make sure we're correct. And we are. And if you subtract the two, PV equals what? 0.7 milliliters. All right. So this problem, number one, was a two-step problem. Step one was to determine the final volume. Step two was to determine the powder volume. Now that you had calculated your final volume from step one, you can now solve the problem by subtracting your final volume and your diluent volume from one another. All right, let's go to number two. Number two reads that a label states that 5 grams quantity of an antibiotic in a bottle should be reconstituted with 8.7 milliliters of saline for injection. The resulting concentration will be 500 milligrams per milliliter. And the question is, what is the powder volume? So as I read that, you can see I pulled out all of those numbers. So let's identify each of those numbers. That 5 grams is considered your total dosage. Your total dosage in detail is considered the weight of the powder. All right. That 8.7 milliliters is the diluent volume, DV. I'm going to put in parentheses, diluent volume. Okay. That 500 milligrams per milliliter is considered your dosage concentration, or your dosage strength. Let me just keep to the same terminology I've been using. This is, 500 milligrams per milliliter is your dosage strength. And then that you're actually looking for your powder volume. But remember, in order to solve that, PV equals FV minus DV. So as you look at your problem, in order to solve your powder volume, you have to make sure that you have the components that's needed. The only component that you have in order to solve this problem is your what? Your diluent volume. So step one is you need to determine the final volume. In order to do that, you're going to take your total dosage, and I'm going to put it in milligrams, which is 5,000 milligrams, over the dosage strength of milligrams, which is 500 milligrams, and multiply it by the dosage strength volume of 1 milliliter. Milligrams cross out. Your final volume is 10 milliliters. Now that you determine what your final volume is, step two is to determine the powder volume. So the formula is still the same. PV equals FV minus DV. You calculated your final volume to be 10 milliliters. The diluent volume that was added was 8.7 milliliters. You subtract the two, and your powder volume for this problem is 1.3 milliliters. All right. And the last practice problem that I have for you guys is this one, number 3. It says that the pharmacy must reconstitute an oral suspension before it can be dispensed to the patient. The dose is to be 250 milligram per teaspoon, which is 5 milliliters. And the dry powder is 5 grams with a powder volume of 8.6 milliliters. They want to know how much water must be added. So, how much water, let me underline that question. How much water must be added? In detail, what do you think it's asking you? How much water must be added? Water is the type of diluent. And if they're asking you how much water must be added, then they must be asking you to determine your what? Your diluent volume. That is what you're looking for in this problem. All right. So let's go ahead and identify our components. That 250 milligram per 5 milliliter is your dosage strength. Okay. That 5 grams is your what? Your total dosage, which is your weight of the powder. That 8.6 milliliters is your powder volume, and you're looking for your diluent volume. So, with that formula, powder volume formula, PV equals FV minus DV, you can manipulate that formula to solve whatever it is that you're looking for. So, for instance, if I'm looking for diluent volume, in this case, what I'll do is I'll manipulate that powder volume formula and just change it to say DV equals FV minus PV. So when you're looking for your diluent volume, all you do is you subtract the final volume for the powder volume. That'll give you your diluent volume. But if you look at the problem, we do not have the final volume. So the first step, step 1, is to determine or calculate the final volume. In order to calculate that, I'm going to take the total dosage in milligrams, which is 5,000 milligrams, over the dosage strength in milligrams, which is 250 milligrams, and multiply it by the dosage strength volume of 5 milliliters, which gives me what? 100 milliliters. Now, so 100 milliliters is what? Your final volume. Now, step 2 is for us to determine the diluent volume. Again, DV equals FV minus PV. My final volume, you guys calculated that to be 100 milliliters in step 1. And the powder volume, they told you in the problem, is 8.6 milliliters. If you subtract the two together, or subtract the two from one another, you get 91.4 milliliters of diluent, which is the water. So you're going to need 91.4 milliliters of water to be added to this 5 gram total dosage to give you a dosage strength of 250 milligram per 5 milliliter. All right, that is the end of Chapter 9, Lecture 6. This is the final lecture for this chapter. Again, if you have any questions, please feel free to send me an email and I'll respond to you as quickly as possible.